Okay, our next lesson is on complex fractions. Not only do we have complex fractions this year, but you're going to see these in trigonometry and beyond. A complex fraction is a fraction inside a fraction. Doesn't that sound like fun? Okay, and it is considered simplified when there is a single fraction and you've got no fractions in the numerator or denominator anymore. So what do we want to do? To simplify one of these, you have to create a single fraction in the numerator and a single fraction in the denominator. You're going to bring the fraction in the numerator down, change division to multiplication, and flip the fraction in the denominator up. Guys, this is keep, change, flip. Remember that a fraction bar is the same as division, right? So complex fractions are just another way to write division problems. Once we've done keep, change, flip, we're going to factor everything, eliminate our common factors, and multiply to get our final answer. These look scary. They're honestly not that bad. So let's take a look. Let's start off with something straightforward. I have a single fraction on top and a single fraction on the bottom. So I'm going to keep the top fraction, 3/14. Change this division to multiplication and flip the bottom fraction over. Now let's eliminate some common factors. 7 goes into 7 once and 14 twice. 3 goes into 3 once and 24 8 times. 1 times 1 is 1. 2 times 8 is 16. Alrighty, I have a single fraction on top and a single fraction on the bottom. So I'm ready to go to keep, change, flip. I'm going to have x minus 1 divided by x. Change this division to multiplication. Flip the second fraction over. Okay, this time I need to factor. So x minus 1 divided by x is already in good shape. It's the denominator of this second one. X plus 1, x minus 1. Now what can I eliminate? The x minus 1s, 1x on top and 1x on the bottom. Final answer, x divided by x plus 1. Okay, I still have a single fraction on top and a single fraction on the bottom. So keep divided by. Change this fraction bar to multiplication. Flip it. Okay, factor. Let's see, plus 4 plus 2. Times b minus 5, b plus 4. Eliminate, my favorite step. Let's see here, b plus 2, b plus 4, b minus 5 over 1, b minus 5. Okay, single fraction over single fraction. So I can keep, change, flip. 2m squared minus 2m minus 40 over 3m plus 12. Division becomes multiplication. Flip. Over factor. Let's see, I can pull out a 2, and then I'll have m squared minus m minus 20. So m plus 4, m minus 5. Right, I did a little noodling in my head here. Feel free to write down that intermediate step. 3m plus 4, 9m, m plus 4, and m squared. My favorite step, m minus 5 is gone. M plus 4 is gone. M and 1 from the bottom. That m plus 4 I'm stuck with. 2 I'm, oh, 3. 3 goes into 3 once, 3 goes into 9 3 times. So 2 times 3 is 6. M plus 4, and we are dividing by m. I think it's gorgeous and so much fun to do. Satisfying to eliminate things. All right, now let's make life a little harder. I have a single fraction for my numerator. That is beautiful. But my denominator, I have 2 fractions. 1 minus something. All right, my least common denominator is going to be the w plus 2. So I need to multiply this by w plus 2 over w plus 2. I still have w over w plus 2 divided by. But now I have w plus 2 minus w over w plus 2. I really need to clean that up before I go any further. So w over w plus 2 divided by w minus w is 0. This is going to be a 2 over w plus 2. I now have a single fraction over a single fraction, so I can keep change flip. W over w plus 2, multiply, flip it. I get to eliminate, and my answer is w over 2. Okay, being able to find those least common denominators and add or subtract fractions becomes critical with complex fractions. Let's look at one that's particularly mean. All right, a plus 3, I like that. Okay, this factors to 5 times a plus 3. So for my numerator, this first fraction needs a 5 over 5. All right, 5a squared plus a squared over 5 times a plus 3 divided by, oh, let's look at this denominator. The first fraction needs to be multiplied by 5 over 5. And the second fraction needs to be multiplied by a plus 3 over a plus 3. Whoa, what did Smartboard just do? Go away. All right, so this is 5a plus a plus 3 divided by 5 times a plus 3. Almost there, right? I'm going to have 5a squared plus a squared. Whoops, 5a squared plus a squared is 6a squared. Combine like terms. and we have 5 times a plus 3 divided by 5a plus a is 6a plus 3 over 5 times a plus 3. I'm ready to keep change flip. 6a squared over 5a plus 3 times 5a plus 3 over 6a plus 3. I need to factor. Let's see. 6a squared over 5a plus 3 times 5a plus 3. I can pull out a GCF of 3. 2a plus 1. Now for the good part. A plus 3s are gone. 5s are gone. 3 goes into 3 once. 3 goes into 6 twice. I have 2a squared divided by 2a plus 1. Okay. Before you write your summary, I will tell you, right, in both of these, we ended up with the same denominator after we found common denominators. That does not always happen. Okay, it's just the way my examples worked out, so don't get too excited about that. Go ahead and write your summary with the critical information that you have to have a single fraction in the numerator and a single fraction in the denominator. So if that means you have to add or subtract fractions before you keep change flip, you have got to do that.